Yes, that's congruent. Very good. What does congruent mean? We talked about that at the beginning of the year. Same shape, same size, equal length, equal measure, things like that. So when we look at what we're talking about today, we're going to talk about this thing called congruency. Congruency is equal measures. And what we start out with, we start talking about this whole thing of congruent figures, if you will, is that we're going to talk in terms of generic things today, a little bit more tomorrow, and then we're going to build into what we call the alphabet soup of geometry. And what I mean by that is, eventually we're going to go back to the two-column proof stuff. And we're going to start doing the two-column proofs with triangles. So what we talk about today is kind of like the big picture of why everything relates to everything else. We've got maybe 3 or 4 definitions, a couple of algebra examples, and then you guys probably have about a good 10 minutes, 10, 15 minutes or so to get started on some stuff. When we're talking about this idea of congruency, it means that we're going to look at figures that have same measurements, equal measurements. And when I'm talking about a figure, I'm talking about it in terms of like a regular old boring polygon. And I'm talking about, if I have a polygon, that means there are sides and that there are angles. So what happens here is that we start and we develop what's called a correspondence, which means that specific angles have to match up within the two figures, which means certain side lengths will match up between the two figures. And what a really, really easy way to show that is to first show you guys what it means by using letters. So I'm going to write out what's called a congruency statement in terms of a triangle, just make it real easy. I'm going to say that we have triangle ABC, and I'm going to say that it's congruent to triangle X, Y, Z. Okay. And when I do that, I want you to see that I'm not drawing a picture of a triangle. No, I'm using stuff for my cell is in charge. Do not use it. I'm using it. Now, when you write out what's called a congruency statement, it's basically telling you the specific order in which things match up. Triangles. How many angles are in a triangle? 3. How many sides are in a triangle? 3. That was a real tough one. Okay. Now, if I say that I have triangle, oh, jeez. Thanks. If I have these two triangles, A, B, C, X, Y, Z, if you follow the lettering, well, before I get into that, remember how we talked about with angles, you can label them with just one letter? When can't you use one letter? Remember that? Well, you're right, but in a triangle, the only time that I can't use 2 letters are... If I have something like that, how many different angle B's could there be? 3. There could be 3 of them. There could be one here, or the whole thing. So, in this case, in our diagram that we have right now, I'm just trying to remind you guys that sometimes it's okay to have just one letter for an angle. Sometimes it's okay that you need to have more than one letter, or you have to have the 3 letters. So, looking at the way that the lettering is written, that tells me a specific correspondence between the parts of the two triangles. Angle A matches angle X. The reason that is because they're both the first letters. Remember how we marked congruency in a triangle with angles? What did we put in the diagram? Little tick marks. So A and X would have to be the same. What does B have to match up with?
Y.
And why does it have to match up together?
Because they're both in the middle.
Correct. Doesn't say anything about any of the angles inside are all the same. We're just matching the letterings, so they have to have this specific correspondence. Which by process of elimination matches what? Yep. So that's what that looks like. That's your angles. How many letters do you use when you're talking about segments? 2 of them, okay? Now, segments are written out in terms of their endpoints, remember that? Endpoints on a triangle are where the vertices are. So A is an endpoint, B is an endpoint. B is an endpoint, C is an endpoint. A is an endpoint, C is an endpoint, which gives you the 3 different segments. So if I'm trying to go through my segments then, watch what happens. Segment AB matches up to what? XY. Now look how you marked it already with your diagram. See how angle A has 1 tick mark and angle B has 2? Isn't that the same exact segment here? Because they match up with the 2 sets of tick marks. That's how we talk about these things. We look for the correspondence. We look to see how they share tick marks, for lack of a better term. Okay? Looking at B and C, 2 tick marks on the angle, 3 tick marks on the angle. That's the same segment as Y, Z, because that's the direction that they're going, between 2 to 3. 2 to 3. And then again, this is what you're left with. So just by having what's called a congruency statement for a triangle, you can actually list out 3 sets of congruent angles and 3 sets of congruent sides, just by looking at the letters. You don't even need a picture of that. You could just say, hey, I've got triangle ABC and XYZ. AB matches to XY, BC matches to YZ, AC matches XZ, because of the way the lettering goes. There's only so many ways you can pattern it out. Not too bad. Now, this allows you to do a whole bunch of things. All right, it's going to allow you to do algebra. It's going to allow you to tell whether or not things are congruent to each other just by looking at diagrams, to write out a statement. Okay? For example, if I look at this next, I think this is the next one. If I look at this next picture, how would I write out that the 2 triangles are congruent? What are the letterings that match? A, B, C, F, E, D. That's one of them. Did everybody see how that looks? I went from 1, 2, 3, 1, 2, 3. So I can triangle. Oh, by the way, you guys know that means triangle, right? Do you have to use that symbol? No. Yes. Okay, yeah. Because if you don't use that symbol, you just use A, B, C, I don't know what you're talking about. I don't know if you're talking about an angle. I don't know if you're talking about a plane or a triangle. So you have to put the symbols here. You can write triangle, but why waste your time? That was a waste of time. That's it. Now, what if I said this? What would CAB have to match up with?
DOB.
See how that works? Everybody see how that works? It doesn't matter where you start, but the lettering order has to match. That's what we talked about, this whole idea of what's called a correspondence. They have to match up within their lettering, I'm not lettering, excuse me, they have to match up within their tick marks. I wish think there's another way of saying tick marks besides like congruency marks. Tick marks. Okay. So that would be, what did I say, C, so 3. Okay. Not too scary. Hopefully. Which then leads you to be able to do this. Let me take a picture of this one real quick. So, how, and write out the congruency statement. Remember, in order to be congruent, you have to have all your corresponding parts that are the same. Everything has to match up. What do you think?
Yeah.
How?
Triangle.
Okay. But
And B has the same angle measure and
okay. But what happens around that angle C? You know, BCA and what is? Okay. What is that called? No. Vertical angles. You guys remember that thing called vertical angles? When angles are vertical, when they're opposite sides create lines, which means that the vertical angles are congruent. That's the one thing you have to be able to put in there to now say that everything is congruent to everything. Now, a long time ago, probably at least a month ago now, we did this stuff. Remember that? Yes, I made a square. Remember your progression sheets, those blue sheets with squares on them? Yeah, I get that out because we're going to use that a lot in chapter 4. A lot. I wanted to make sure that we have those still. If we don't have those, I've got a couple extras. I'll have to make more. But I think as of right now, we have. I know we had midpoints, angle bisectors, linear pairs, perpendicular. We may or may not have talked about angle pairs on there. I know eventually we will go back and revisit that. Sir. You gotta find the patch that's falling over. Does that anybody else need one? I've got a couple extras. Right here. Anybody else need one? Like I said, I've got 5.
Or Mr. Murphy,
What?
can I go get my binder?
What?
Can I go just get my binder?
What's your binder with you?
We don't always get sheets.
So, oh, I'm sorry. You got to be louder than that. Do you want one? I can't hear you. What? What? I know, but it's funny to watch how fast her face got red though. You can say thank you. You're welcome. All right. Look for vertical angles. The reason why I want you guys to put this on your progression sheet is because it's one of the things that you can always take from a diagram. When you have diagrams, you can always pick up certain parts. For example, one of the things we always imply on the diagram is vertical angles, reflexive sides, which we'll talk about eventually, and right angles. Especially because right angles, you know what they are because they'll have a little square in the bottom, a square in the corners. Those are the few things you're able to take from diagrams. Now, what I want you to do is draw a little picture of kind of what we have there. We have a kind of like a bow tie-ish looking thing. I'm just going to call this angle 1 and angle 2. And if you recall, on some of the progression pieces, we wrote it in terms of what we call the 2-column proof, a statement, then a reason, what you're saying and why. Well, my example here would be something like this. Statement, reasons. I could say angle 1 congruent to angle 2. Oh, you're going to. I can say angle 1 is congruent to angle 2 because the reason is vertical angles are congruent. And that's going to be something you're going to be allowed to use pretty much whenever you have, well, obviously, you can use it whenever you have vertical angles. This is something you're going to be able to state without having to come up with something else. Okay? It's one of those nice things that's it's a little bit of a, I don't want to say breather, but it's a little bit of a hint, if you will. It's a nice hint for specific types of diagrams that you'll wind up with in the proofs as we get there. Okay? Now, don't lose this sheet. This sheet is really, it's going to be gold here in about another week, because I know we probably won't use too much of it tomorrow, but I know for certain come next Monday and throughout the all next week, we're going to start using more and doing more and more triangle proofs, which means you'll be given specific information between two triangles, and you're going to have to prove that they are congruent. Well, the way the textbook stuff works with a lot of it is they're going to give you maybe a third of the information. You have to figure out the rest. Well, this progression sheet, you know, for example, there you guys have midpoint. So if you have midpoint, you would say, well, some two segments are congruent to each other. The reason, definition of midpoint. Those are the types of things that we're going to be able to take from this to a specific proof here in about a couple of days. Okay? Probably won't start tomorrow because it's the weekend and the Lord knows you want to do it anyway. So why fight it? Right? Doesn't take a rocket science to know that high school kids ain't gonna do anything on the weekend until it's late on Sunday night as they're texting each other, well, is the homework? Or they're copying it to each other on Monday morning at their lockers.
I don't.
Oh, am I wrong? Okay. What's that? No, I'm just doing this is something else. Now, this is back to the normal stuff here. I don't think I'm going to add any more to the progression stuff today. There really isn't much left for right now to get to. But one thing I do want to look at is we all know how many degrees are inside of a triangle, right? There's 180 of them in there. So if I'm looking at those two triangles, I have a 50-degree angle, a 60-degree angle. How much is left then for angle B? Yes, that would be 70, okay. Same thing on the other side, what do you know? They have to be 70, okay. Now, here's the reason why that happens. What's 50 plus 60? What's 50 plus 60? Does 110 equal 110? So if I subtract that from 180, what am I always going to be left with? Will that number ever change? So what happens here is that you get this thing called a third angle theorem. And what that means is this. If two angles in a triangle are congruent to two angles in a different triangle. So basically I have a 50 degree, a 50 degree, 60 degree, and a 60 degree. Two angles in one triangle are congruent to two angles in a different triangle. The third angles have to be congruent. What's that?
Yeah, we have that before. Triangles and
Did we?
something like that.
There's a lot of little similarities, but I don't think we actually really defined this before. It's really easy to see. I mean, even if I didn't define that for you, you would have figured it out because it has to be, okay? This is a little shortcut thing that you'll see from time to time. I don't think we'll have to, you're not gonna have to worry about it so much today as far as any proof stuff is concerned. If we do come across something with a proof, which we will, we'll make sure we put it in our progression sheet, but it's not something, this is more of an algebra thing that you'll see. This is more of an algebra thing. So again, if you've got two angles that are congruent between two triangles, that means the third angles between the two triangles are also the same. Because it has to be. Because math won't math otherwise. Marker. Let's do another algebra. All right, let me ask you this. Just real fast. Look at the letters. What angle are you given with a degree value? What angle is that? Can we just say D? Can I just say it's D? Okay. Now, if I say that this is D, that's the fourth letter, right? What's the fourth letter in the other one? Okay. So do I need to even worry about writing anything out? Because I know right away, just by looking at the information, these two have to be equal. I know that 8y minus 9 has to be 47. Okay? See where I'm going with that?
Yeah.
So a lot of times when you get into these larger, like you say, oh, that's awful. There's a lot going on in the diagram. If you start piecing it together about what do you really need from the diagram, you can get less out of it. AE. AE is first last. What does that match up to? First last, doesn't it? Which means that 3x plus 4 has to be 10, right? Will that change ever? Do I need to do those two algebra problems?
Yes.
Okay. I do want to solve for x and y. What do I do first to solve for x? I said x as I was looking at y, so I was like, why am I subtracting 4 from 9? And then I realized, like, oh, that's right, I said x. What's x? What do you do to solve for y? You add the 9, we get what? 8y 56. Y is? Once again, the algebra that you're going to see is really, really, really quick. Okay? There really isn't a lot of, there's no craziness here. We don't get to crazy algebra, honestly, until we get into some trick stuff later on. Okay? That's about one. What's that? Yeah, we do a little bit. We'll do, just your regular old SOHCAHTOA, and then we'll do some law signs. You know the buttons on your calculator? Sine, cosine, tangent? SOHCAHTOA. Stands for. You'll be there, don't worry. It was right on the board here like a week ago.
Okay, I didn't remember where I saw it.
You do this. All right, do these. This is in the textbook. I know it looks like there's a lot. It's not, because the first 8 problems are off of a diagram. It says basically angle X is congruent to what other angle?
Y.
Angle Y is congruent to what other angle? All you're doing is looking at a diagram going back and forth. I think it's the last 6 problems, I want to say, 5 or 6 problems that have a little bit of algebra to them. What? Apparently geometry is so do me a favor. Take your croak books out. I hear it's riveting. Or riveting. Croak, rivet. Anyway. Screenshot it, do whatever. Take a picture of it, text it back and forth. Go ahead and get started. I guarantee, I know we got about And then, so most of you guys should be able to fly through the first, like I said, first 10 questions are just what do they match up with. Okay? We'll do some more of this stuff tomorrow, probably a little bit more algebra. Have a little bit of time in class, that kind of stuff.